And welcome everybody. If it's Wednesday, it's the PentaBAR by Pentalog. Welcome here in this cozy space of Zoom. Thank you for registering. And Pentalog is organizing this series of PentaBARs all over the world. Now we're in Mexico with this time Jesus Raimundo Cabrera Vargas, and I'll tell you more about him. He's a senior data engineer at Pentalog Mexico. And we'll talk on the interesting subject of keeping up with the future through data engineering. So we'll talk about data engineering and we'll learn what a data-driven company is and why the number of these companies is actually increasing. We'll look at the data roles and their differences. For example, the data engineer versus the scientist. We will see what's a toolkit and the processes, the specific processes of data engineering, and the scenario that we'll have as an example, and we hope for some interactions between us. And if you're still here by the end, you will get the tech trends that our colleagues will put there, and we'll get to stay in touch through other interesting pentabars that you can all follow. They will be in English. So let me present Jesus Raimundo, and he's a senior data engineer with over 12 years of experience in building data solutions. He was also been interested in learning new technologies and everything that's innovative in IT. And he started as a .NET developer, but one day he discovered the world of data where technical knowledge can be easy transform, as he says, into solutions to help businesses make better decisions. And also I trust in that. Of course, not really if we're not taking into account our assumptions and intuitions, but we'll see his take on that, yeah? The best part of data is that it always makes you think outside of box, and I do believe this is true. So let's welcome Ray here. Ray, how are you today?
Hi, all good, thank you. Happy to be here.
It's good to hear. I heard you just had a meeting, stand-up, no?
Yeah, I just get out of it.
Yeah, perfect, perfect. Those rituals are so good for, you know, keeping the rhythm going.
Yeah, they are.
You have here, so just for the for our guests, you have the sections of the Q&A if you feel to put any questions all along of the presentations. I will facilitate that, and I'll interrupt Ray, and we'll prioritize your questions, and we'll be in this exchange in making it really valuable for yourselves. So Ray, what would you say is the importance of data?
Well, right now, for many companies, data is like the most valuable resource they have. And this is because there has never been so much data or so much information in the world. Right now, everything is managed through data. You can say smartphones, sensors, vehicles, any digital artifact have data, and all the data they have can be used in different ways from the companies, usually to, well, help them to produce more benefits, more revenue, for marketing. There are many different things that can be done with that. So right now, data is becoming really important, and data-driven decisions for the companies are like one of the top strategies that are out there right now.
I know you have some very interesting statistics in, you know, how much data is created and what's the fuss about it and what's the buzz about it and why the companies are increasing. Would you share it with us?
Yeah, sure. Actually, well, so you get an idea. Probably data is measured by bytes. That is a measure of the data. Probably you have heard of kilobytes, megabytes, gigabytes, even terabytes that are like probably a hard disk on your computer can have a terabyte. But there are many other units that go after that are millions or billions of bytes. And well, right now data is going through those. For example, every day we have like 500 million tweets that are sent. We have 65 billion messages on WhatsApp. YouTube is uploading 700,000 hours of videos every day, every single day. So every minute we have like 500 new hours of videos in this platform. That means a lot, 3,000 minutes of video per hour. And right now, in a common day, all this data together, it's 2.5 quintillion bytes. That measure is an exabyte. That means 2.25 and 18 zeros. This is the equivalent to 10 million Blu-ray discs. And just so you can imagine the size of that, if you stack all those Blu-rays one above the other, you will get the height of the Eiffel Tower 4 times. That's the amount of data we have today.
Thank you for the analogy, because that, I mean, the measurements were, at least for me, are pretty strange looking at those like that.
Yeah, and the amazing thing of this is that this is by today, by 2020, we have that measures, but it's estimated that to 2025, we will have 463 exabytes of daily data. This means 200 more times the data that we have today. So this will be a huge amount of data in 4 more years. So yeah, this is growing.
You know the saying, may you live in interesting times, is already happening since last year. So we'll see how data will contribute also to that. And let's go further with our encounter until we enter the really examples and the techie side. What do you really mean by a data-driven company? Because as far as I know, from my perspective, a lot of companies say that they use data, but being data-driven, it's a bit of another thing.
Yeah, basically a data-driven company is a company that can transform the data into monetizable assets or into revenue. That's what it means. These are companies that make decisions based on data. They treat the data as a strategic asset for the company and make it like wide available for everybody. Everybody can contribute to this. Well, basically that's what a data-driven company does. And there are many advantages on data-driven companies. For example, I check some statistics. Being a data person, I like to check a lot of statistics. So I see that I check that data-driven companies are 23 times more likely to acquire new customers. They also increase their profits by an 8% if they use data-driven decisions. And also, well, data-driven companies are growing at 30% each year, and they are predicted that over these years, in 2021, data-driven companies will take over $1.8 trillion annually from the less informed companies. So right now, it's a trend. Data-driven companies are making huge things. Probably I could give you a couple of examples of companies that have done this and different ways they have doing. I mentioned that there are many ways of use data. For example, it can be used for business decisions. One company that do this a lot is Amazon. I'm pretty sure everybody has heard of Amazon or at least buy something there. And basically what Amazon is doing, a business decision, is the recommendation they give to the customers. They check what items you have bought in the past. They see what have you ranked, what have you reviewed, what are the purchases that other customers have done similar to you, and they start popping up these recommendations to you. And this has been a big deal to them. These recommendations have increased the sales of Amazon in a huge way. Usually they are pretty accurate and make people buy more things that they actually start thinking of doing. This is all driven by data. Other company that use data-driven decisions is Netflix. They do for marketing, not for selling. One example I hear about in Netflix is in 2017 they launched their first original film. Name is Bright. It was a movie starring Will Smith. I think it was poorly rated by many websites like Rotten Tomatoes, but anyway, the movie got 11 million views on the first 3 days. So that's a lot, and it was not just by luck. The thing is that even this movie was premiered on December 2017. It started marketing on March. And the way they do this, it was by analyzing data of the viewers. They catalog what they were seeing and run some algorithms so they can display specific trailers, clips, or even visual things that may be interesting for the individuals over time, so they can get engaged to this movie. One thing that Netflix is doing great above other platforms and even the movies or the movie theaters, as we know, is that they think that every night could be a premiere night. This means that, for example, this movie, Bright, it aired on December 2017, but probably somebody that haven't seen it yet can be a trailer pop out today, and for them will be something new, and probably they'll watch it today, and today will be their premiere night. So that's something that Netflix is doing. And another way that data can be used is for companies to help to make human resources decisions. One company that is
I'm interested
data.
in that. I used to work in human resources. I'm doing coaching training. So yeah, how come?
Actually, that's what data-driven decisions can help in human resources. Big company Google, pretty sure that's something we all know. They take all decisions data-driven. Anything they do it by data. Actually, they have tons of data. They have most data than any other company there. And they created this department called the People Analytics. At first, they started this just like getting reviews and service to the employees. They review their manager, how they are feeling, how the performance was. So they start looking at the things that have better managers perform better and work longer in Google. So once they have this information, they don't stop there. And this is a very important part of data, or at least of data analysis. Don't stop with the first thing, ask more questions. So Google then asks, okay, we have this, but what is what makes a good manager? So Google created some new things like a Great Manager Award that encourage employees to nominate managers and also managers to make an extra effort to get these awards. So again, by performing more reviews and getting interviews with the managers, with the person, they come with a list of good behaviors to managers. And also they have now a lot of training programs for managers to make them more, well, make them work better and get more engaged in the company. So all this was because of data they collected.
Yeah, they do a great job also in creating a psychological safety environment, which we know that's important, and measuring that by data, it's critical. So let's see what are they doing in order to manage all this data. They must be doing something. I mean, this must be doing something.
Yeah, actually there is a process. It's kind of straightforward. It may vary a little bit between companies, between the size of the data. That's something that is really, really important as well. But basically the process that data needs to go through is first data collection, that is gathering data from any source out there. All the data that the company have can be gathered, can be collected. Then the data needs to be clean.
Yeah.
This means remove anything that doesn't work, probably make the data a little better, more understandable, make it make sense. That's kind of the thing. Then with clean data, companies can start exploration. Here's when the interesting part starts, because in this exploration, they can start discovering things, they can start to see patterns, they can do like a better analysis of the data, they start to get answers of questions. For example, Google, what makes a good manager? Probably in exploration, they can do it. Once there is enough data and enough exploration, and you already have your questions and know where to look for the answers, and companies can start working on machine learning models or artificial intelligence models. So they can automate responses, they can make decisions based on these. That's like the process that comes or that needs to be done. This process is done by many different people. Don't think that this is just data engineering work. Um, the part of collection and cleaning data is usually made by data engineers. Usually, the exploration is done by data analysts or business intelligence analysts. And finally, building machine learning models is done by data scientists. But this is not exclusive to these roles. I mean, sometimes data engineers can go on build a machine learning model. Sometimes data analyst can go and help cleansing the data, or probably a data science can be involved in all the process and collecting the data, cleaning it. So this is not something exclusive to the roles. This depends a lot in how companies work and how the people can do. Yeah.
To make sure that I understand, we have collection, then we have the data cleaning and making sense of it, then we have exploration, and then we have building models upon that. Yeah. And on collection and cleaning, we have data engineers. Then going forward with exploration, we have mainly the analysts, and then building the models, they're the scientists. Not resuming only to that, but it depends on the frame.
Yeah, exactly.
I can be a data scientist now. I got it correctly. Cool. So that's the broader choice. Is data engineering a good career choice?
Well, personally, for me, yes, it is.
Why so?
As we talked earlier, the data need in the companies is growing a lot. Many companies want to go data-driven, so there are a lot of more openings in this career path for people. So yeah, I think it's a career that is growing a lot, at least now.
And what do you need to do in order to become a data engineer?
Well, I will say there are many steps that needs to be followed. The thing is, a data engineer is a multidisciplinary career. It's not like just learning about one technology. You have to learn a lot of things. I will tell you about how I become a data engineer. It was actually kind of by luck. I never thought about becoming data engineer. When I was studying in my career, it was some years ago. I graduated and I was thinking of becoming a .NET developer. .NET was the technology I have been using since years ago in the school. I also have making small projects and stuff. So I got hired by the company. I get there and I thought that I would be doing .NET stuff, but the funding is that put me on the database side. So I started making reports, making queries, and I like it. It was something that I enjoyed, like just looking at information. After that, I moved to another company. Again, I was thinking I was going to be a developer again, but no, because my expertise, I getting the same thing, more reporting, more databases. But that time I started growing more on the database administration side. I started working with more technical stuff, more procedure, more programming using SQL, using databases. So after that, I jumped to a next level that is called ETL. And I think we will talk about that later. But basically, it's the kind of the base of the data engineering. I didn't know it at that time. It was something that I really enjoyed. I really like that, like moving data, creating more reports about the data, having more control, modeling data. And well, the things still get changing. I start programming again in Python. So my previous knowledge in .NET helped me to know to start working with this technology, this program technology. Nothing to do with I have done before, because working with data is kind of different than making a system or making a program. But I have to learn that. I start learning more more data concept like data warehousing, like data lakes, other stuff like that. And yeah, that was like 6 years ago, and I'm still doing that.
So what
So
I mean, I have a curiosity here. From I mean, you know, every part of the truth has different facets to it. So what advice would you give, you know, like developers, teams in using data or using more data on how to integrate data more in their practice?
well, first of all, treat data as a valuable resource and try to answer every question with data. At the end, is information we have, is the knowledge we have is there. So you have any question, you need to solve a problem. I'm pretty sure that data can do it. You can find the answer there. And yeah, I think that's my advice to use data more. And well, if you want to become a data engineer, I think there are many things that need to be taken into consideration. First, you will need to know strong development skills. Like I said, probably Python, Scala, R, anything. You have to get a huge understanding of databases and just not focus on one database. You have to learn many different kind of databases, NoSQL databases, SQL databases, anything. You need to know about data processing techniques. That's another thing. You need to know a little bit about what big data is. That basically, big data is data in a massive amount of data. It's called big data.
Let's maybe get to some examples, and we open the stage for the questions also. If you can share a bit of the cases that you have and you have been working through.
Sure. Actually, well, one of the things that I see is one time a company I joined, we started the data engineering team because something they did wrong. The thing is, this company just look at these data-driven decisions, and they was like, "Hey, this is awesome. I want to do it here. I want to have a data scientist team that make machine learning models and help me to get decisions, to get forecasting, and to get the best things out of my data." So they started and hired a team of about 30 people of data scientists. When they come to the company, they see that they have a lot of data, but the data was not useful to them. They cannot do anything with the data because data was not structured in a way that worked for analysis or that worked for them to do machine learning. So the company struggled, they tried to do what they can do, but after a couple of months, the team was dismissed and, well, the project ended there. Then hired a new data engineering team. I was there, starting there in the company. And the first thing we checked was that actually they have a database in Redshift, but it was not for analysis. Yeah, it have a bad structure. It has a lot of bad data, wrong rows, wrong information. Also, when reporting teams go and do queries on that, it was really, really slow. I mean, there were some reports that could be crucial for the investors, and they took like 2 hours to run. So that was not doable. So the first thing we do was try to move that to a working database.
What does that mean, a working database?
Well, more than a working database, move it to a different schema. For example, this was like all the structured data, and we plan to create a warehouse. A warehouse is a database schema where data is distributed a little bit different. So in theory, it will be faster to query, and also will have to answer the business questions they have. For example, what, where, when, like how many, I don't know, how many sales we have last week, what are our revenue, that kind of stuff. And we also make some research and compare some other technologies for this data warehouse. So we come with Snowflake. That's something that I really like. We make some numbers, and because of the speed that we were saving there, the timings, and also the licenses between using Amazon Redshift and Snowflake, we were saving the company around $100,000 yearly just in licenses. Doesn't considering all the time savings. So basically, this project was to build anything from zero and put it there in that new schema. We make a lot more things there after that, but yeah, that's kind of a big project that I work with. Also, other thing that happens a lot that is kind of the things that I'm used to is in other projects we have the salespeople have like these top customers that they really love. They really have a special treatment to them. But the way they identify them was like just looking at numbers, right? Like, okay, this customer have a lot of transactions. He is top customer. But that was it. That's the only thing they think about. Like, okay, he haven't spent more than 5,000 the last month, so he's a top customer. But they just do it by looking at the numbers. So we built some data structure to gather data from all the different sources because we are not just considering the sales. For example, some of these customers waste a lot of time with customer service calls, and that costs the company money. Also, probably they have a lot of transactions, but those are small transactions, and this transaction costs money to the company. So even if they do well, like million transaction, but they are super small transaction, probably cents of transaction, is costing more money than actual profit to the company. So we start gathering this data from different sources, put it together, and our data science teams come with a real accurate algorithm to get the real top customers for the company. Yeah, that's the other thing that we do. Other project that comes to my mind is I used to work on a company that have these card terminals, and they started doing this called like no card payments, where they send you a web link, you just open it, put your credit card data, and you pay for the links. But there were a lot of fraud in this, so the only requirement we got is we need something to help us to detect this fraud. So again, as a data engineer, I have to look through all the data we already have, like transactions, and not only our transaction, we have to go and check probably credit card numbers. This information was in another place, not in the usual transaction place. So we have to gather everything together. And yeah, we start finding some interesting patterns. For example, there were some people that tried to make a same person, same client, try to do like 20 payments in less than 10 minutes for $1 every 10 seconds with different credit cards. So we can say this person is trying to do a fraud. Or for example, we detect something that probably they do a $1 payment, then a 5, then 10, then 100, and they do it in the same credit card in difference of probably seconds. That's because they are trying to like drain the money from the credit card, and we start marking that transaction as dangerous. So again, data scientist team come with some model, with some algorithms to detect this, and as soon as this come to the databases, we were able to call the person that will take care of this. So those some of the things that I think.
Those are some very nice examples. We have some questions gathering also. So just, I mean, in preparing to go to the scenario, because we'll pass through a scenario together, we're going one, they say, hello guys, I have maybe a very basic questions, haha, but I'm starting to get interested in all these data science topics. So I still struggle to understand what is the data warehouse and how is that different from a database.
Okay, well, data warehouse is a type of database, but usually a database, as we know, database is a structured database. It works perfectly with application or with systems, but when it comes to answer questions, it can be really complicated to find data in there. It's like probably there are a lot of data that is not useful, probably a lot of records that are well, that are, I don't want to call them like trash, but records that are not meaningful to an analyst or to a business person. So a warehouse is a way to put all this data together and make it for analysis. Like,
So it's after cleaning, as I understand it.
Exactly. It's like a clean database, especially designed for analysis, to the business analyst, to the data analyst, so they can go there, get answers, and get it fast as possible.
Okay.
Because, probably you need to see only data for the last month. That's the only thing that matters. And you go to your database and you have like 3 years of data, and to find a record there, it will take you a lot of time. But probably in a warehouse, you can have a current month table, and that's the only thing that you would be seeing. So it will be way faster. Also, the structure is different.
Okay.
Yeah,
We have some others. Having data analysis, now that we've cleaned the data and we're in the warehouse in mind, are there any key points that should be considered when a database is being set up?
Well, I think it will be the same, that the data is clean, that the data is, well, let's say, correct data, that it have the right form, that the data you have there is aimed for the correct people, also that querying it is efficiently as possible. Sometimes data analysts or the tools they use are not that powerful. So if you have data scattered around 20, 30 tables, making query these or making a query to get this information can be a pain for the data analyst. So try to keep it simple. That will be the best advice there.
Okay. And related to that, another question in the chat this time. The raw input data received needs to be cleaned, as we said, in order to be used. Is this process done manually by data engineers, or there are software? I imagine there are softwares, but can you name some that help cleaning it following certain rules imposed by the data engineer? How does that actually work?
Well, this is usually done manually, but by the use of a software.
Okay.
So it's like a combination of yeah. Let's say, I mentioned earlier something called ETL.
ETL, yeah, okay. What does that stand for?
Yeah, it stands for extract, transform, and load data. It's like the most basic framework in data engineering. And there are software that are specific, dedicated to this. For example, this is one called Pentaho, Informatica Power Center, Data Stage. Those are ETL softwares, and they make things pretty easy because they help to collect the data, and they already have pre-made functions to clean the data. For example, you can basically right-click and say delete duplicated, or you can drag two tables together and join them. That's the kind of things that you can do there. But also there are more manual ways to do it. For example, with Python scripting, you can take the data and start cleaning it manually. Also, even in Python or in other technologies, you have like these options to, okay, if you find an empty row, remove it. If there is an empty value in this column, replace it with this default, some stuff like that. So I don't know if it makes sense.
Okay, cool. And two more questions, at least until now. What is the difference between a junior and a senior data engineer? Is this the amount of knowledge built into the work experience, or was the work experience with the knowledge that you had from the junior level? I don't really get it, but maybe you do.
Well, I think the difference is like the same in that every other area. Is basically that the work experience you have. Probably a junior data engineer know how to do the things, but need to be like guided through all the steps, and probably still need to ask a lot of questions about how the things work. And there are many things that just come with experience, like, for example, how much processing or how to process the data, what is the best way to do it, or for example, designing a data warehouse is something that in papers sounds pretty easy, like, okay, just take what you need and put it here. But actually you have to start thinking beyond that. Sometimes it's like, okay, I know that if I do this, this will happen. Or in my previous experience, I know that also this data could be useful, so I will put it there. I will make it available for later, this kind of thing. So I think the only difference is experience. The experience you get, the more you work, the more senior you get in this.
And what's your opinion, Diego is asking, on the relationship of data science and mathematics?
Well, a lot. It's pretty related. Most of the machine learning
Because you're building
algorithms,
models, no?
exactly. Most of those models, machine learning models, are math models. Actually, many of the functions you will see there are mathematical functions, math functions. So yeah, if you want to become a data scientist, you have to love math. That's something that you will be seeing on a daily basis. It's required to be a data science.
Okay. And broader questions, do you feel that the pandemics accelerated companies to become more data-driven? Companies that favor data-driven decision-making are more likely to successfully manage the crisis or recover faster?
I think yes. I think actually, yeah. If you see there is more data right now, and getting back to Amazon, when the pandemic started and everybody was ordering from Amazon, you see that the one day delivery changed and they start delivering 3-4 days after you purchase something. I think they, well, learning from that and probably improve their delivery process by data. Now that most people is working from home, doing shopping from home, doing everything in the computer, I think there is more data than it was before. So in that part, yeah, I think the pandemic made data-driven companies grow and yeah, more popular in some way. I don't know if by having data-driven companies or data-driven decisions will help to get out of the pandemic, but it would be nice to find like an algorithm that help us to get the vaccine or something faster.
Yeah, for sure we're in a marketing funnel and we're not really beating the algorithms in taking decisions now. So they know they're built on neuroscience and psychological, cues, and for sure they know better in how to drive us drive our purchasing behaviors. So if we go further from here, I know you have a scenario. Maybe that will broaden our understanding on how to look at the data.
Yeah, sure.
And
yes.
Before you share all that, is another question. Batch processing is dead. I don't know what that means, but maybe you can.
Yeah, I will explain what batch processing is. Actually, there are two ways of processing data. One is streaming, one is batch processing. The difference between these is the streaming is like having the data in real time. Let's say you make a purchase and immediately you see it in your credit card. So that's kind of a stream. And batch processing is when you take a bunch of data and move it from one place to other, but probably you can do it every 3 hours, daily, probably once a month. And no, it's not that. Actually, many companies for reporting, they use batch processing. And for many other things, they use batch processing. There is data that is not that important or you doesn't care about seeing it like in real time. So you can do a batch processing of that. For example, let's say, well, kind of in the scenario I'm planning to, but reporting data, you have a weekly or monthly report. You don't want to see that updated every day because you don't have the whole month data there. So you can wait till the end of the month and batch process the whole month data and send it to the your end site. So no, batch processing is not that.
Okay. So let's go to the scenario. And until you open that, just to mention that if you want to watch more PentaBARs, Our colleagues here have put in the chat a link you can subscribe to. We have from the more, conceptual type of pentabars, where we'll talk about product, development, product marketing, managing teams, project management, agile, to the really live coding, kata, and you see, JavaScript, and you'll see some others there. So check the ones that you like. We have from the mindsets to very techy sites on all these axes, and please subscribe there. And at the end, we'll have the feedback, and we'll have also a giveaway in the tech trends. So maybe even before going there, one other questions. I am building reports in Excel, and I had, of course, a course in SQL. What do you think? This is enough to try applying for data analyst?
Yeah, actually, that would be a good start. Like, data analyst job is basically that, building reports and querying data from SQL. But because there are many data analysis tools out there, some of them doesn't require even that you know a lot of SQL, at least like the basic. Is more like what can you take from the data that you can like really extract the valuable data from there and present in a way that your target audience or your target person can understand, and yeah, that it's useful to them. So I think it's a great start to work with reporting and SQL to get that data analyst job.
Okay. Cool. So let's go to the scenario. I'm eager to.
So can you see my screen now?
I'm screening. It's still it's a white one still, but yeah. I think it's on purpose.
Okay, this is a fictional scenario, but this is like a basic thing that happen in data engineering day-to-day job. This is something that have happened to me, and I'm pretty sure most of the data engineers, ETL developers have worked in something like this. So for this scenario, we'll have a company that sell some kind of food supplement, right? But this company, the only way to get this supplement is the customer can go and buy it from a physical store. And everything's going fine until there. Everybody's happy. They go to the store, get their supplement, and that's it. But someday, somebody open a website for sales, and people can go and buy their supplement here. But there is a catch. They can only buy when they have an invite. And to get this invite, they can only get it from a physical store. So the idea of that is because the revenue or the profits of the website sale have to go to a physical store. So that will be like what is going on with the company. So
it sounds like the public administration in some country to open to get online access, you have to go physically to get it.
There are many places where you have to do that. So as I say, this is not so apart from reality.
Okay.
So let's say in this company, there is a data analyst that create a report every week, a weekly report, and it goes to a business manager people or some person of business. And this report contains the sales that every physical store did during the day, right? But when he starts checking the report, he sees that the website data is not there. They don't have this data in the report, so report is wrong. It's not what he's expecting for. So what they have to do is call the data engineer, and he had to jump in and fix this issue. So first of all, the first thing as a data engineer you have to do is what is what you need. In this case, you will need to create this report, to have the data to create this report. So first thing you could do is talk to the data analyst and say, okay, where are you getting the information from this report? It happens that they have a database in Snowflake where they read the data for the report. So, okay, now you know what would be your target for the data that you will be gathering. Next thing, you already know that there is a sales software and you already have that information. So you have to see what that information looks like. So The engineers goes, talk to the sales software developer, and he says, okay, I have that information, and this information is in a Redshift database, right? After that, let's go to the website developer, and he say, okay, yes, I have this sales information, but I can only provide it to you in a JSON format. That's the best I can do. And okay, it's okay, but once you check the information, you see that you don't have a relationship between these sales here and the actual physical store they come from. So you go to the physical store and ask, oh, I need to know what customer did you send an invite to? And they say, okay, yeah, we have a Excel spreadsheet with this relationship. And believe it or not, many companies still use Excel spreadsheet or plain text files as a database. It happens more often than it should. Really common scenario right here.
Heard about that, yeah.
So what should we do? Okay, the thing is we have to gather all these technologies together. We have to put them together. And what tool we can use? Okay, we can use probably Spark. That is a processing tool, very powerful. Probably this is small information. Also Hadoop. We can use Databricks. All of these are more focused on big data. Probably it will be a ways to use these things. So what about we use Python, the simplest scripting tool that comes to my mind. So probably we could put together all this with Python. Probably we can use a library called PySpark that will help a lot to gather everything together. So now we define this and we can start working on this. So the project or the idea of doing this will look like this, right? Please let me know if I'm getting clear. But we
have two questions. They're not exactly about that, but maybe, I just want to take advantage and encourage other questions. Stop us whenever you feel by a question in the Q&A action, and we'll explain. Mm-hmm. So, good data project engineer for a beginner. Where can you get some useful data needed to build a data warehouse, data lake, and make it available for analysis? So maybe you share that just briefly before going forward.
Well,
and if you know free tools or platforms to build the project.
Yeah. Okay, well, free tools, platforms, it depends. As I just mentioned, there are many different things where you can build a data architecture. But for free tools, probably Python, Scala, R. There are many libraries that are free and work for this. There is also a ETL tool called PentaBAR. I think it has a free version that is very powerful and it's a good start for that. Database, well, basically any database that can be for free. And for the other question, good project to begin with probably will be something similar to this. This is something really basic. Probably you can try to gather data from different sources, probably create a small stream from a NoSQL database. And when I say stream, is like if you make a change on your NoSQL database, you can see it immediately in other side. Maybe just pop your message. That kind of things will be a good starting project for data engineering.
Mm-hmm. Okay, we can go forward.
Okay. I will go on here.
Yeah.
Well, as I was saying, we already know what we will have these three sources of information. So first thing, we will need to collect all of this data. We will need to process it and send it to the final analytics database that the data analysts already provide us. Let's say this is the structure they want. They only want to see the date, the name of the store, and the total amount they sold. That's the only thing. You see here, we have a lot of data. It's pretty different between each other. It even have different column names, probably different formats. We don't know. We have to go through that. And well, what we have to do is put everything together, right? So the first thing here will be taking these two things because we want to know these cells to which store they belong. So by using PySpark, we can combine these two data sets into a big data set that will be looked like this. Now we will have the data of the web customer, the store name, the invitation, the sale, and the amount. This is like a combined data. Right now, this is part of the cleaning data, or if we see it in an ETL, this is part of the transforming the data. So basically, we have to join these two tables. Probably it's not that easy. Sometimes the IDs don't match, so you have to work around it. Probably the data columns have different types and you have to work around it. Probably they don't have the same data and you have to work around it. I don't know, probably you get it. The next step will be like combining now these two. That will be you already combined website sales with customer with the physical store sales, that this is something that you want to see. So after combining it, you will see something like this, right? With all the data. As you can see, in physical store, we don't have invitation. And if you see this data, still it is not what they are requesting. They want to see only one store, one date, and one amount. You will have the same store can be here twice with different customers, same day probably, different amounts. So we still need to do more cleaning on this data. So we have to go on. And now this data, we do more cleaning. And at the end, we are getting this kind of data set that is the clean data. And we still have this in Python, in our PySpark session or in processing tool. You can call it Scala, Spark, Hadoop. You will have like this data there in memory, and you have to put it in our nth target. That will be this Snowflake database. So this data, again, going through PySpark, you have to put it here into a table, and probably it will look like this. You can say, okay, this is completed. So you can go to the data analyst, tell them, okay, I have the data, can you please check? They can go through it, check the report, and probably tell you, okay, this was a total success. And there is one more thing here. This is like the data structure we use created. This thing is called a data pipeline. And a data pipeline, basically you can compare it to a water pipe where you gather water from many sources. You put it together probably in a big place where you can, again, put it into the houses, right? Move it to the houses. That is a data pipeline, basically gathering data from many places, processing it together and sending it to a final source. But the thing is here is that you still need to run this script, and you will not do it manually every single week, right? Because probably you will have this data available at midnight and you don't want to go there login at midnight and run it. So there are something that is called scheduling tools. There are some really complex, there are other easy to use. Even Linux cruns can work in this. So you can put everything in a scheduling tool. In this case, I use select Apache Airflow because it's a good scheduling tools that have like good debugging, or you can catch a lot of errors there. And you can say, okay, run this every single week. And as a question I was asked before, this will be a batch processing process. So basically, you will have this data pipeline that solves the problem that we have at first. So this is the most basic scenario that a data engineer have to face, moving data from one place to other, cleaning it, and presenting to the data analyst or to the business person that is interested in it. I don't know if it makes sense or.
Mhm. It sounds good. Just to announce that my colleagues will also post the tech trends that will be available just for you to have it, and we'll have to round it up and land the plane, Ray, whenever you're ready.
Sorry, come again.
What?
Yeah, sorry, didn't get that last.
No, I was saying that the tech trends, the colleagues I'm seeing now on the chat, so whoever wants to subscribe there and get the latest trends of 2021,
Okay.
check this one. And as we're preparing to finish also. And before concluding, yeah, if there are questions or. And there's one question: in Python, the most widely used programming language, is Python the most widely used programming language in data science?
I think he's one of the most. I'm not sure if he's still the most used. I could say that it was, but right now Scala is gaining a lot of weight because it have pretty good integration with Spark, that is one of the most popular processing tools. So I don't know if it's the most
What, what,
used, but at
what
least
is
it's
it
one.
used for mainly?
Python?
Yeah.
Well, the thing is, Python is really um, flexible. It can be used for many things. It can be used for development. It can use for scripting, for data science,
No,
for data engineering.
they were that was the questions in this area. Yeah.
Yeah, but yeah, it's really used. There are a lot of libraries that support the data science work in Python. There is one called PySci-Learn, I think is the name.
Mhm.
That it's a library focused 100% on data science, on creating models, on presenting these models. So it's one of the most used technologies for data science. That's for true.
Okay. Anything else? Any more questions? My colleagues will also put the feedback form here, just for you to have it. It will be deeply appreciated if we get a feedback to ever improve our pentabars. So what are some key takeaways, Ray, until our colleagues will complete the feedback? If our participants would be left with some key messages from this, what would you want them to go with about data?
Well, first of all, that they understand the importance of data and not only in the business, also in your daily basis, because you want it or not, you are in contact with data every single day. When you have like these tracking devices that take your heart rate, that count your paces, that kind of things, it's data, and you are like seeing statistics of data, and they are helping you to have a healthier life, probably. When you use your GPS, when you use to get from one place to other, they help you to skip the traffic or stuff. You are using data. So data is not exclusive for business, it's for everybody there, and it's something really, really important. That's something that I want every people to understand or to get. And also in the part of the business, data-driven decisions are the best that a company can do, at least for now. And they are more, yep, yeah, go, Mihai.
No, go ahead, go ahead. I was
Yeah,
confirming, I deeply feel this one.
yeah, as I mentioned earlier, it can grow the benefits of a company, the profit by a lot. Also, in the human resources side, or by doing good data analysis, you can keep people happy. You can make people that last longer in their works, that work harder, that work better. Yeah, I think data is useful for any single aspect of your life.
So thank you very much, Ray. That was explained even for me to understand, and that's brilliant. It's not in every pentabar that I get to see that. So if you want to
Thanks.
subscribe to the others and go even more techie or even lower in growth mindset and some softer skills, you can have it all by subscribing. Next week, will run from Bucharest and Paris, the PentaBAR, and it will be on Agile with a very nice Agile specialist and consultant who has transformed several companies and will dig into some Agile thinking, mindset, and methodologies. You stay tuned and you will see that. Subscribe to the PentaBARs. Thank you, Ray, one more time. It was a pleasure to facilitate this PentaBAR in Mexico, and I'll come with pleasure every time, virtually, at least until now. Although that might be a good idea to go there. I'm Mihai Zânt. I'm a coach and a trainer and entrepreneur, and I was glad to have you here. Thanks.
Thank you, Mihai.